Hi there, year 3. Welcome back to week 2 of summer 2. Today we are going to be talking about line symmetry. Now already when we think of line symmetry, there should be a key word that is coming into your head that sounds very similar to symmetry. Hopefully you said symmetrical, and that is exactly pretty much what it is. So one side looks quite the same as the other and they're quite equal. So either they split in half or quarters or eighths, whatever. But when you compare them, they're the same part, they're equal sides. So here we have an example. The shape is symmetrical. So this almost looks like a one part really, and then it's been put the same time into 4 parts. So this, they flipped it and it's the same over here. Diagonally, it's the same. And over here on the other side, it's also the same. Now here, we also have it with shapes. So if I took my square or rectangle, it should be a square, but it kind of looks like a rectangle here. If I folded it over this corner to this corner, that would be the same. They wouldn't overlap. It'd be a perfect match. And then same, top to bottom, if I folded it this way, so my fold was there, also, it would be the same because they wouldn't overlap as long as you fold it perfectly. Same thing with a star. This point would match up to this point. This point would match up to this point, and this would be perfectly centered. Triangle as well here. And then an arrow even, because these 2 points, those vertices would touch each other as well, and they would match up. So if you folded it, you'd fold it perfectly in half in this case. And then even here, you could do quarters. So let's have a look at this. Now we have different types of symmetry and line symmetry as well. So we have translation, where it's kind of moved over. So you've kind of flipped it. We have reflection. So just like if you were to look in a mirror, rotation. So they've rotated it around to a different degree. And then a glide reflection, which is kind of everything together as well. But we are going to just be focusing on reflective symmetry today. So reflective symmetry, very similar, and that's where we get the name from, is from your reflection. So this might be a reflection in a mirror, it might be a reflection from water, whatever. So for instance, in this photograph, we can see that there is, the line of symmetry is right across. So it's being reflected in the water, the same exact image, the same length, the same shape, it's being reflected. Same here with the mountain. Now here we have a shape that they made. So they've made it with a straight edge here. Then they've made these ones sticking out. What do you think might happen if they reflect it in a mirror? What do you think? Let's have a look. It's almost made kind of a star, a 6-pointed star. So even though this person's shape was only these parts with the 3 triangles coming out of it, when it's in its reflective symmetry, it looks like a 6-pointed star with our line of symmetry being across this way. It could have also been across, if they rotated it, it could be across this way and this way as well. There's lots of possibilities. So let's have a look at this. A shape has a line of symmetry if pretty much you can draw or fold a line through it so that one part is exactly the same as the other part. So for example, I have my piece of paper. As long as I fold it perfectly, one part, this part, it's the same. And you can tell because I don't have any coming from the other side. And that is my line of symmetry there. So there we have the 2 parts and my line of symmetry is there because when they're folded, it's the exact same. They have the same amount, same length, etc. All of these shapes have one line of symmetry. So if I were to fold it to this, again, this edge would meet here, vertices, etc. They would all match up perfectly. One wouldn't be overlapping. They've put the line perfectly where it should be. If you moved it here, that wouldn't be symmetrical because one part would be worth more, kind of similar to when we talked about fractions. Now here you can see that I have folded the circle here. So originally I had a circle. The fold shows one line of symmetry. So when he folded it, similar to what I did, it shows one line of symmetry. Then I've put the mirror on the fold and each part matches. And when I look in the mirror, I can see the whole circle. The fold does show a line of symmetry. So similar here, if you were the mirror and I put it there, it would open and we would see a rectangle. So I've kind of done an example with the green shape here. That would be if I put my paper against a mirror, I would see the rest of it. So I know my line of symmetry is here. When I open my shape up, luckily with this one you can see it because it's a nice fold, so you can see it there. Now, shapes can actually have two lines of symmetry. So you can see here with that rectangle, we can fold it top bottom, so these points would match, but we could also fold it the other way. So this point would match this point. Same thing with this oval, this edge would meet this, or we could have folded it top to bottom. Here are some other shapes. So let's see, how many lines of symmetry does a square have? What do you think? Diagonally, top to bottom, across. Think about it, visualize it. If you have a square, go for it. Try to fold it, see what happens. Let's see. That's one, that's two, that's three, that's four. A square has four lines of symmetry. So you can do it this way diagonally. So these points match. You can do it this diagonally. Those points touch and match. So alignment symmetry is there. You can do top to bottom. So it's across there and then over that way. And so the line of symmetry is in the middle as well. So a square has four lines of symmetry. Oh, what do we think here? How many lines does this shape have? Ready? Is it symmetric? Does it have zero? Well, I'm not sure. What do you think? One, two, more than two? Let's see. So if we put it there, these points would match up. So that's one line. Because what would happen if I put my line here? Well, that wouldn't work because this would just go to here. And it would, all these points would overlap. So this is not, it only has this one line of symmetry. There we are. Let's check this one now. There's a lot more points here. What do we think? Let's have a look. That's one, two lines. So one going down the middle, top to bottom, one also going across. The line actually isn't perfect, it should go a little bit over that way. So then you can really see that. Yes, diagonally wouldn't work here because you'd have an overlap, wouldn't you? There we are. Oh, our triangle. What do we think for a triangle? Top to bottom, would that work? If I moved this over here, is there anything to match it? Across, if I made this corner touch this one, would that work? Diagonally, what do we think? Let's see. Top to bottom, diagonally, it has three lines of symmetry, which, funny enough, it has three sides and three lines of symmetry. So this time, they've done it across, which we thought about, but even diagonally still works, because look here, if I just color this shape, this is that diagonal point, that has the same value as the other side. Look at this way, this shape, so if our line of symmetry is there, I'll color this one in. This one has the same value, the same amount as its other side. So that's perfect. So you see, even with a triangle, it's not just that one, there's three lines of symmetry. All right, well, your task today is you have these shapes. You can, if you'd like to, cut them out and then fold the shape. So I would actually cut along the line here. So you have the shape and then fold it and see how to make it perfect. Now remember, when you're folding it, really concentrate on folding so the edges match up perfectly. You have your corners that are matched up. Because of course, If I were to fold it like this, it would not be symmetrical because I have one that's overlapping the other. Now here, I showed you this way, but as well, I could have folded it this way, like we saw. So I'm gonna match up my corners, nice and neat there, matching, looking, making sure that one's not overlapping the other. And I'm gonna carefully fold down, looking, making sure the corners are together, folding all the way down. And so you see here, there's another line of symmetry. One is not overlapping the other. I can open it up. I can see that line really well. So same thing here. You could cut these out, fold it and see. If you can visualize it as well, that's perfect. And just have a think. Where could I put that line? If I put a line down the middle here, would that match up if I folded it there? If I put a line from this end, my line's not straight, but if I put a line from this end to that end and folded it, would that match up? Would they be perfect? Well, this one looks very similar to our rectangles here, but notice they have kind of a indent here. So what would happen, even if I fold here, would that be a perfect matchup? Same thing here. What would happen if I folded this in half this way? Would that match up there? So have a think and then you sort it. So are there any shapes that have 0 lines of symmetry? Is there one with 1 line of symmetry? Are there any with 2 or more lines of symmetry? And then you can either draw it or you can stick it in. I think probably the best thing to do today is cut these out, play around with them, fold them to see your lines of symmetry, and then stick them into the correct place. And then you can take a picture of it and send it to us. But have a go at that. We've also set some Conquer Maths work on symmetry. And yeah, so we hope you enjoy that. And even a purple mash, nice reflective drawing one. So we're sure you're gonna have fun with that. Right, see you tomorrow. Bye-bye.